Hello grade 10 students. Welcome to this video lesson. I am Madhu Vadke. Today we will start with a new chapter, chapter number 5, Arithmetic Progressions. In today's video class, we will learn some basic terms and definitions related to an AP. We will also learn how to write the terms of an AP and identify whether given list of numbers is an AP or not. Consider the following list of numbers. Observe the pattern in each list. Try to write down the next number of the list by understanding the pattern. Let's write down the fixed number that we are adding to the previous number to obtain the next number. So in the first list, if you observe the pattern, the number that we have added is 1. So the next number will be 5, 6, 7, so on. Look at the second pattern. The first number is 100, the second number is 70, third is 40, fourth is 10. So we see that the numbers are decreasing by 30. So the fixed number that is added in this is minus 30. We are subtracting 30 to get the next number, but we can say the same thing as we are adding minus 30 to the previous number to get the next number. So the next number here will be minus 20, then minus 50, and so on. Look at the third list of numbers. Minus 3, minus 2, minus 1, 0. So we are adding 1 to the previous number. So the next number will be 1, 2, 3, and so on. In the fourth list, to get the second number we add nothing, to get the third number we add nothing. In other words, we are adding 0. So the fixed number here is 0, and what should be the next number in this list? 3, 3, and so on. So in the list given here, there is a definite pattern, and this pattern is obtained by adding a fixed number to the previous number to obtain the next number. Such list of number is called as AP or arithmetic progression, and the fixed number that we are adding is called common difference and is denoted by D. Now the common difference, as you can observe, can be positive, negative, and it can be 0. But remember, it is always the number that is added. So when we have common difference as negative number, then the list of numbers goes on decreasing. So now that we have understood what is arithmetic progression, let's write down a definition. Arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So let's write down a general form for an AP. Consider a list of numbers as A1, A2, A3, A4, and so on. These numbers are called as terms of the AP. So A1, A2, A3, and A4 are terms of the AP. A1 is the first term, A2 is the second term, A3 is the third term. The numbers written as subscript indicate which term of the AP this number is. Now to write down an AP, what is the minimum information required? We know that the next number of the AP is obtained by adding a fixed number to the preceding term. So obviously we need the first term of the AP. So let the first term of AP, which is A1, be equal to A. Can we write the AP just with the first term? No. We also need the fixed number that we need to add to A in order to obtain the next number. So we need the common difference as well. So now the first term is A. The second term will be A1 plus D, which is A plus D. The third term will be A2 plus D, which is A plus D plus D, which can be written as A plus 2D. So now we can write an AP that has first term A, second term as A plus D, third term as A plus 2D, and so on. So if we know the first term and the common difference, we can write down the AP like this. And if a list of numbers is given, like in this example, we can check if the given list of numbers is AP by verifying that the common difference is same. That means the difference between any two consecutive numbers should be same. For example, 70 minus 100 is minus 30, 40 minus 70 is minus 30, and 10 minus 40 is also minus 30. That is, A2 minus A1 should be same as A3 minus A2, should be same as A4 minus A3. That is common difference. With this knowledge, let us identify whether the given situations are AP or not. This example is from exercise 5.1, question number 1. The cost of digging a well after every meter of digging, when it costs rupees 150 for first meter and rises by rupees 50 for each subsequent meter. For the first meter, the cost of digging is 150. So the first term of the AP is 150, which is A. The cost rises by 50 for each subsequent meter. So the increase in the cost is represented by the common difference D, that is 50. So the first term is A1, which is 150. A2 is 150 plus the common difference 200. A3 will be A2 plus D. That will be 200 plus 50, 250. A4 will be A3 plus D, 300, and so on. So this given situation is an AP, and it can be written as 150, 200, 250, 300, and so on. As we can see that the difference between two consecutive numbers is always 50. So this list of numbers is an AP. Second example, the amount of money in the account every year when rupees 10,000 is deposited at compound interest is 8% per annum. The formula to calculate interest each year is given by principal into rate divided by 100 into the time, which is 1 year. The principal amount is 10,000 rupees, and this is going to be the first term because we start the account with 10,000. Now for the second year, the amount is calculated by adding the interest on 10,000 to 10,000 rupees. So that is given by 10,000 plus interest on 10,000. So that is equal to 10,000 plus 10,000 into 8 upon 100 times the time, and the time is 1 year. So on calculating this, we get 10,800 rupees. For the third year, the amount will be principal amount at the starting of the year plus the interest. That will be 10,800 times 8 upon 100 into the time 1. 10,800 is the amount available at the end of the second year, which becomes the principal for the third year. And then we calculate the interest for this current year and then add to the principal amount. So this total comes out to be 10,800 plus the interest 864, that is equal to 11,664 rupees. Likewise, we can calculate the amount at the end of each year. So the list of numbers that we have is 10,000, 10,800, 11,664, and so on. These are the terms of the given list of numbers. So A2 minus A1 comes out to be 800. But if I find A3 minus A2, then it comes out to be 864. Since A2 minus A1 is not equal to A3 minus A2, this example is not an AP. Let's find whether the third situation is an AP or not. The amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Let the cylinder have X amount of gas in it initially. So the first term will be X units. Vacuum pump removes 1/4 of the air remaining in the cylinder. So after removing 1/4, we are left with X minus 1 by 4x. This will be the second term of the list, which is given by 3 by 4x units. So after removing 1/4 of the air, we are left with 3 by 4 of the volume of gas in the cylinder, and that is the second term. Now what is remaining in the cylinder? 3 by 4x. From the remaining gas, we remove 1 by 4 of the remaining gas. So we get 9/16x units. This will be the third term. Likewise, we can find the fourth term, which will be obtained by subtracting 1/4 of the remaining gas from the gas that is in the cylinder. And on calculating this expression, we will get 27/64x. So the list of numbers is x, 3/4x, 9/16x, 27/64x, and so on. On finding A2 minus A1, we get 3/4 minus x, which is equal to minus 1/4 x. On finding A3 minus A2, we get 9/16 x minus 3/4 x, which is equal to minus 3/16 x. So we can clearly see that A2 minus A1 is not equal to A3 minus A2. Therefore, this list of numbers is not an AP. Second question of the same exercise. Write first 4 terms of the AP when the first term A and the common difference D are given as follows. The first term A1 will be A, that is minus 1.25. The second term A2 will be A plus D, adding the common difference to the previous term. So minus 1.25 minus 0.25 will give us minus 1.5. The third term will be A2 plus D. So to the previous number minus 1.5, we add the common difference, that is minus 1.75. The fourth term is obtained by adding common difference to the third term. So we get minus 1.75 plus minus 0.25, that is equal to minus 2.00. So we have got 4 terms of this AP, and that is given by minus 1.25 minus 1.5 minus 1.75 minus 2.00. Question number 3 of the same exercise. For the following APs, write the first term and the common difference. It's already given in the question that these list of numbers are APs. 4 terms of the AP are given, that is A1, A2, A3 and A4. So the first term is minus 5. The common difference can be obtained by either A2 minus A1 or A3 minus A2 or A4 minus A3. So that is equal to minus 1 minus minus 5, which is minus 1 plus 5, which is 4. In the second problem, 4 terms are given. So the first term is 1/3. Common difference will be A2 minus A1, that is 5/3 minus 1/3, which is 4/3. Question number 4. Which of the following are APs? If they form an AP, find the common difference D and write 3 more terms. To check if the given list of numbers is an AP, we have to show that A2 minus A1, A3 minus A2 and A4 minus A3 all are same. So this is A1, A2, A3, A4 and so on. So let's find A2 minus A1, that is equal to 0.22 minus 0.2, which is 0.02. A3 minus A2 is 0.222 minus 0.22, which is equal to 0.002. Now we don't need to find A4 minus A3 because we have already shown that the common difference is not same. So since A2 minus A1 is not equal to A3 minus A2, this example is not an AP. In the second question, we have a list of irrational numbers. In order to find whether this list is an AP, we will have to simplify each term. So root 2 is already in its simplest form. Now root 8 is root of 2 into 2 into 2. That can be written as 2 root 2, because square root of 2 into 2 can be written as 2. Now root 18 can be written as square root of 2 into 9, and square root of 9 is 3. So root 18 is 3 root 2. Likewise, root 32 is square root of 2 to the power 5. That can be written as 4 root 2. Now labeling the terms and finding the common difference A2 minus A1, that is 2 root 2 minus root 2, we get root 2. Find A3 minus A2, that will be 3 root 2 minus 2 root 2, which is root 2. A4 minus A3 is 4 root 2 minus 3 root 2, that is also root 2. So the consecutive terms on subtracting give us the same difference. So this implies that this list of numbers is an AP. Question number 3, root 3, root 6, root 9, root 12. We follow the same method. First we simplify each term. Root 3 cannot be simplified further. Likewise, root 6 also cannot be simplified, but root 9 can be written as 3, and root 12 will be 2 root 3. Now if we subtract A2 from A1, we get root 6 minus root 3. A3 minus A2 is equal to 3 minus root 6. It can clearly be seen that A2 minus A1 is not equal to A3 minus A2. So this implies this example is not an AP. Question number 4. Let us simplify each term. So we get 1, 25, 49, 73 and so on. Finding A2 minus A1, 25 minus 1, that is 24. Finding A3 minus A2, that is 49 minus 25, that is 24. A4 minus A3, 73 minus 49, and that is also 24. So this implies, since the common difference is same, that this example is an AP. Next question is already solved. Pause the video and go through the steps. Since the common difference root 2 is same for any two consecutive terms, this is an AP. Question number 4, the second part is to write 3 more terms if the given list of numbers is an AP. So we skip the first example because this is not an AP. In the second example, since this is an AP, to write the next 3 numbers, we will have to add the common difference to the previous number. So root 2, 2 root 2, 3 root 2, 4 root 2, adding one more root 2 to 4 root 2, we get 5 root 2, then 6 root 2, 7 root 2, and so on. So we have written 3 more terms of this AP. Question number 3, this is not an AP, so we don't need to write the terms. Question number 4 is an AP, so let's write down 3 more terms by adding the common difference to the previous term. So 1 square, 5 square, 7 square, 73. Now the next number will be obtained by adding 24 to 73, which is 97. The next number will be obtained by adding 24 to 97, and that is 121, which can be written as 11 square. To get the next number, add 24 to 121, we get 145. Fifth example is also an AP, so let's write down 3 more terms. So 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2. Looking at the pattern, the common difference is root 2. So adding root 2 to 3 plus 3 root 2, we get 3 plus 4 root 2, 3 plus 5 root 2, and 3 plus 6 root 2. That is all in today's video lesson. Your assignment for today is exercise 5.1. Question number 1, subpart 1. Subpart 2, 3 and 4 are already done in the video lesson. Question number 2, subpart 5 is already done in the video lesson, so remaining our homework. From question number 3, subpart 2 and 3 are already done, so the homework is subpart 1 and 4. And fourth question of the same exercise, we have done part 6, 12, 15, 13 and 5, remaining to be done as assignment. See you in the next class with another concept on AP. Until then, goodbye.